So we open with our MIT open source license, and we've gone ahead and made comments out for the cities that we are most interested in. We've chosen 10 here based on the top 10 cities to live in the United States from a 2012 list. So we go ahead and import the necessary modules, import OS and import ArcPy, and then we go ahead and establish our base directories. Like we have our base directory, and just depending on where exactly it is located, this source might change. So we have a temporary directory as well, where we will store some of our temporary files, and a map directory where our maps will be generated. Okay, also we have a few more directories here just to establish. We have an airport directory, Walmart directory, and a hospital directory, basically where our shape files with this information is located. And then we create a data set, we call it data files, and we are going to want to list that directory so we can see everything inside of it, see everything inside of this data files, and then we want to go ahead and create another variable, and we're going to call it PDF path, map the directory plus the atlas PDF, which is what we're going to name it.
Okay. Now this is so we're just going to do a quick little if statement, and this is just going to say, if this PDF path already exists, then let's remove it. Now PDF doc is going to be the actual PDF document that we create, and it's going to be located at the PDF path. Now, so our data files is a list of all the files in our base directory, and now we're going to loop through each directory, or each directory within our base directory, which we basically have a file for each city. So we're going to, so this is an if statement, just says if it is a directory, then let's give us a little print, little message to just kind of measure where we are in the code. Now we're going to loop through every directory within the base directory. So we're creating more variables to just kind of simplify our base directory plus this new city, that we're in, plus the airport directory, which is where the shape files are located.
Okay, now this next portion of code, we've gone ahead and we've defined all of our loop variables, the variables that we're looping through: hospital, hospital shape, Walmart, Walmart shape, etc. And we've gone ahead and we've identified each layer that we're going to create, or each shape file that we create, and they're identified here in either a base directory or a temporary directory, as you can see. City points is the temporary directory plus the city points layer. City freeways is a shape, temporary directory plus city freeway shape. The temporary directory is temporary, and that's something that we are not going to be keeping.
That's right. So this arcpy.env basically just overwrites anything that we loop through that's already been created. If it's already been created, then we just replace it. Another message to kind of tell us where we are in the code. And then we're going to take a break. We're going to just do this little pass command to let ArcMap catch up with us. Now, we do this series of creating points. So our first command is to create points within our city limits, which is basically our selected city shapefile. And then we're going to create the hold on. So city points is actually the shape file, and then we output selected city _ shape.
Yeah, so from this process, once we've created these points, we're going to go ahead and create a city points layer. So now we've gone ahead and we've created this layer, and from this layer of points, we are going to create a buffer based on the city shapefile. So now we've got this buffer of points around this area, and we're in the next line of code, we go ahead and with that buffered area, we make a clip, and we're going to make a clip based on the freeways or the high class roads, the 4-mile buffer, which is a shapefile we just created, and the city freeways. And once again, we're going to take a break to let the processing catch up with itself.
So now this is where we kind of geoprocess through the different criteria for these best locations. So one of our criteria is vicinity with a freeway within the city. Basically, we don't want to be too far away from the city or from the freeway, but we don't want to be too close to the freeway. So this first one basically selects everything within 4 miles of a freeway. And then the next one deselects everything within 0.5 miles of a freeway. So that kind of gives us that optimal distance between 0.5 and 4 miles. And now we do the same thing with the Walmarts. Now these distances are, we want to be within 3 miles of the Walmart, but not within 1 mile. So between 1 and 3 miles from a Walmart.
And one thing that was unique between these two sets is the freeway shapefile is a line. It's a linear file, whereas the Walmart are points. So one was creating a buffer, where the other one was creating a buffered zone around a point.
Right, right. And now we have the similar setup with the airports. We just don't want to be within 4 miles of an airport. So the farther away from an airport, the better, is what we decided. Now with a hospital, we want to be close enough to a hospital, but not too close. So we selected everything within 3 miles of a hospital, but then we've deselected everything within 1 mile of a hospital. And now this next line of code basically creates another shapefile with all of these selections that we've just created. So all these selections becomes our premier selection shapefile. And since all of these were created with points, and points were generated, now we aggregate all those points into one shapefile. Into this best area shapefile is what we've called it.
Yeah, the best area shapefile, that's the one we're most interested in. And once again, we've gone ahead and we've taken a break to let the processing catch up with itself. And just to see where we're going, we print refreshing map view and exporting the map, because the map has generally been created, and now we're just going to make sure that we set up the PDF or the map document with all of its title and its legend all displayed.
Okay, so we start off with this MXD variable, which is just our current map document that we already have opened in ArcMap. Now, these next lines of code is we define a variable called all layers, and then we loop through all layers, and that's to basically clear the selection or deselect everything that we selected previously in the geoprocessing. And then we refresh our active view and refresh our table of contents. Now we set up a SQL search, which is basically it's going to look for a keyword city, and then it's gonna tack on basically the city name. So we're searching for that city name. Then we do a select analysis where we've got the shapefile called selected city buffer, which was that original buffer that we created, and we perform the SQL search, and then we output a shape layer called temp selected. Our df variable is our current data frame, or a list of all the data frames, but since we only have one, it's the current data frame. So our current layer is a list of all the layers in the map document, but then we've selected our temp selected layer, which is what we had currently selected from our SQL search within that data frame. And now we select by attribute, once again by that SQL search. And then we zoom to that selection, so that kind of gets our current city right in the center of our map. Now once we've zoomed to it, we can clear the selection so we don't have anything selected. Now this next portion is where we loop through all the layers in our current map document. And we basically decide which layers we want to have visible and which layers we want to hide. So the ones that we decided we want to have visible are our base map. And the base map had a couple of sub layers, and in order to get it to work, we had to say that we wanted the National Geographic, which was a sublayer, as well as the Nat Geo World Map, which was also a sublayer. We had to say all of those were visible in order to get them to actually be visible in our map. And then we have our best area layer, and then our selected city buffer layer. And we say if it's one of those layers, then we want to make it visible. If it's not, then we want to hide it. Then we do another if statement, and this basically says this specific layer, the selected city buff layer, we want it 50% transparent. Then we refresh our active view and refresh our table of contents. Now we've defined a new variable called elm, and elm is basically just a list of all of the elements, more specifically our text element. And now we have, this is our wildcard right here, and we have one of our elements named my city, so we want to specifically select my city. That my city element, which is a text element, which ends up being the title of our map document, or our PDF. Now we say elm.text, which that text, we want that text to equal F, which is the city name. Then we refresh our active view. And then this leg or variable that we've created is basically our legend element. So we've selected our legend element, and since we were having issues with our legend being crazy sizes, we've defined that it had to be narrowed down to 1 column size. So that's just to kind of keep it in the right size that we wanted. Now we define a variable called path PDF, which is different than PDF path, and path PDF is the path name for our specific PDF that we're creating for the city that we're looping through right at that moment. And then we export that PDF, so we're creating the PDF.
So now we're going to just go ahead and, like we have before, we're going to take a small break, let the processing run up. And then just to keep a track of where we are in the code, we're going to have the code print creating the PDF map, print change layout, done. And as soon as that's done processing, once again, we're going to have it print appending PDF maps to Atlas. And then this PDF doc.append pages is where we're going ahead and we're taking that new PDF that we've just created at PDF path and appending it to the PDF document. And then PDF doc dot save and close. So it creates that PDF document, it saves it, and it closes it. Okay, so we're going ahead and we're beginning our code. First, we're just going to open up our template file. And then it's just going to pull up what our map is going to look like when it's all said and done. We've got a little due north arrow. We've got the best locations for living title and the Carmel, Indiana, which that title is going to change as the code runs, and our legend, of course, and our legend will change as well. So we're just going to go ahead and load the Python script, like we all know how to do. Here it is. And we'll begin to process. Okay, so the code is beginning to process right now. It's thinking about things. And it already says it's printed that it's accessing the files. It's geoprocessing best area. And we've got a start time show up here in the bottom right of the screen. There we go. And now it's begun. And just like we discussed earlier, it's created the random points. It's made a feature layer. It's buffered it. And now we've clipped that buffer. And you're going to watch the scale of the legend change as this goes through because it's mapping the directory right now, but we change the name as it processes. And now we're focusing on a location. We've selected the layer based on that location. And now we're selecting it again, but now it's using a different point. It's buffering, it's clipping, and now we're creating the selection. And now it's taking all those selected points and it's aggregating them into one layer called best area. And now we're selecting that layer by its individual attributes. Allowing it to continue to process. And now we've got a polygon. We've got a polygon generated, a few polygons generated with the buffered area around our city. And now it looks like we have a proper legend and everything illustrated with the layout changed, and it's confirmed right here on the right. Done. So now we go ahead and we look in our directory, the PDF directory, and it opens up right here, and we've got our PDF, and this is exactly what our code we wanted it to do, and we've got the legend, and you can see that we've got the best area, the select city buffer for Carmel, Indiana. And I was going to go ahead and process this for the next 9 cities, and we'll come back at the end. Okay, so here we've got the final PDF that we pulled up. We've gone ahead and executed all the PDFs, and we'll go ahead and show it to you. We've got Carmel, Indiana, Chapel Hill, Columbia, Eden, Irvine, McKinney, Newton, Overland Park, Redmond, and Reston, Virginia. And we opened up the Atlas PDF right here, which is the containing folder for all 10 PDFs. And we'll go ahead and we'll quickly work through them right here. The polygons that were generated right here, you can see inside the buffer area. We'll just point them out right here, you can see. And those little polygons were the best area. So you can see some are much more small than others, like clearly here in Chapel Hill with a very small triangular area. Very unimpressive area to say. We'll go ahead and zoom out here real quick so we can get a better view. But we can see here, like in Columbia, there's a much more large spread. Yeah, the areas of interest that we've selected are really all in different areas, but based on the buffer zones, this is what we were able to find out. Irvine, California right here. Yeah, the legends were scaled, the titles have changed, all according to our script. Overland Park right here, we've got, if you look closely, you can kind of see the highway right down the center, and the buffer off that highway, and you've got your perfect living space. Also the same right here. Redmond, Washington. And Reston, Virginia, our very last one. Yeah, this one shows the buffer zone really well. Our script ran to completion really well, just as we anticipated, and there it is.